Imagine looking up at the night sky and finding a world that, by every rule astronomers thought they understood, simply should not exist. A planet peacefully circling the burnt-out remains of a dead star. Not a bright living sun like ours, not a young energetic star still forming planets, a dead one. When NASA and astronomers studying distant star systems confirmed this extraordinary discovery, it raised a question that sounded more like science fiction than science. How could any planet survive the violent death of its own star? Because when stars like our sun die, they don't fade away quietly. They become monsters. They swell into enormous red giants, expanding so far that nearby planets are swallowed whole. Temperatures rise to thousands of degrees. Entire worlds are vaporized. Gravity shifts violently. Anything that once orbited peacefully is expected to be destroyed forever. At least, that's what scientists believed. Yet somewhere hundreds of light years away, a planet was still there, still orbiting, still defying everything researchers expected. And that mystery would soon become one of the strangest stories in modern astronomy. For decades, astronomers believed that once a star reached the end of its life, its planetary system was essentially finished. Stars spend billions of years converting hydrogen into helium through nuclear fusion, but eventually the fuel begins to run out. Without enough energy pushing outward, gravity starts winning the battle. The star expands dramatically into a gigantic red giant. If our own sun ever reaches this stage, about 5 billion years from now, it will likely consume Mercury and Venus. Some models even suggest Earth itself may not survive. After shedding its outer layers into space, the remaining core collapses into an incredibly dense object known as a white dwarf. A white dwarf isn't producing new energy. It's simply the glowing ember left behind after the star has died. Roughly the size of Earth, yet containing about half the mass of our sun. Just 1 teaspoon of white dwarf material would weigh several tons on Earth. It's one of the densest objects in the universe. For years, scientists assumed that any close orbiting planets would have been destroyed long before the white dwarf appeared. So astronomers weren't expecting to find new planetary systems around these dead stars. Then something unexpected happened. NASA's planet hunting missions, along with powerful telescopes on Earth, kept collecting enormous amounts of data. Tiny dips in starlight, minute changes in gravity, almost invisible signals buried inside years of observations. Most of these signals turned out to be false alarms, instrument errors, background stars, random noise. But every once in a while, one signal refused to disappear. Researchers checked it again and again. Different observatories examined the same star. Independent teams compared their calculations. Instead of fading away, the evidence became stronger. There really was something orbiting this white dwarf. The object completed its orbit with remarkable consistency, producing exactly the kind of signal expected from a planet. Not debris, not another star, a planet. That alone would have been astonishing, but the real surprise came when scientists calculated its orbit. It wasn't drifting far away from the dead star. It was orbiting surprisingly close. Close enough that according to earlier theories, it should never have survived the red giant phase. Somehow, against overwhelming odds, this world was still there. Or perhaps it hadn't survived at all. Maybe it had formed after the star died. If that were true, astronomers would have to rethink one of the biggest assumptions about how planetary systems are born. Could planets actually form twice? Once around a living star, and again around its dead remains? That possibility seemed almost impossible, yet observations continued pointing in that direction. Around the world, astronomers began digging through older telescope archives, wondering whether they had overlooked similar systems for years. Slowly, another realization emerged. This might not be a single cosmic accident. It could be evidence that the universe has been hiding an entirely new class of planetary systems all along. And if planets can exist around dead stars, then perhaps life has been looking in places humanity never thought to search. But the next discovery would be even more shocking. Scientists found clues suggesting this strange planet wasn't the only survivor, and what surrounded the dead star would challenge everything we thought we knew about the fate of solar systems. For years, astronomers believed that a white dwarf marked the end of a planetary system's story. But as more powerful telescopes scanned the skies, a surprising pattern began to emerge. The lonely planet wasn't the only mystery. Around several white dwarfs, scientists detected dusty rings of shattered rock and metal. These weren't ordinary asteroid belts. They were the broken remains of planets and moons that had been torn apart by the white dwarf's immense gravity. It was the aftermath of a cosmic catastrophe. Entire worlds had been destroyed, leaving behind streams of debris slowly spiraling toward the dead star. But hidden within that destruction was an unexpected clue. Computer simulations showed that surviving planets farther away could gradually migrate inward over millions or even billions of years. As the star lost mass during its death, gravity throughout the system changed dramatically. Planetary orbits became unstable. Giant planets could pull smaller worlds into completely new paths. In other words, a planet that is close to a white dwarf today may not have been close when the star was alive. It could have spent billions of years in a safe, distant orbit before slowly moving inward long after the violent red giant phase had ended. That idea solved one mystery, but it opened another. If planets can migrate after a star dies, how many more are waiting to be found? Astronomers began searching with renewed excitement. Using data from space observatories and ground-based telescopes, they found more evidence that white dwarfs are far from quiet. Some showed signatures of heavy elements like iron, magnesium, and calcium in their atmospheres. Normally, these elements should sink beneath the surface of a white dwarf very quickly. So why were they still there? The most likely explanation was astonishing. The dead stars were actively pulling in material from nearby rocky objects, asteroids, moons, or even the remains of planets. It was like reading the chemical fingerprints of worlds that no longer existed. For the first time, scientists could study the composition of ancient exoplanets long after they had been destroyed. Every new observation revealed another piece of the puzzle. Some systems appeared chaotic, others seemed surprisingly stable, and a few looked capable of holding planets in long-term orbits for billions of years. That possibility has changed how astronomers think about the future of our own solar system. One day, the Sun will become a white dwarf. Mercury and Venus will almost certainly be gone. Earth's fate remains uncertain. The outer planets, Mars, Jupiter, Saturn, Uranus, and Neptune, are expected to survive, though their orbits will change as the Sun loses much of its mass. Far in the future, our solar system could resemble some of the strange white dwarf systems astronomers are discovering today. It's a reminder that the universe rarely follows the simple endings we imagine. Stars die, worlds are destroyed, yet somehow new stories continue. Perhaps the greatest lesson from this discovery isn't about one extraordinary planet. It's about how science constantly evolves. For decades, textbooks described white dwarfs as the quiet graves of planetary systems. Today, they're becoming laboratories where astronomers are uncovering new physics, testing theories of planetary evolution, and discovering that the aftermath of stellar death may be far more dynamic than anyone expected. With next-generation observatories becoming even more powerful, researchers hope to find many more planets orbiting white dwarfs in the coming years. Each discovery will help answer questions that once seemed impossible. Can planets truly survive a dying star? Can entirely new planetary systems emerge afterward? Could distant moons remain habitable for a time under the faint heat of a white dwarf? And perhaps the biggest question of all, if life ever existed in one of these systems, could it somehow endure long after its sun had died? We don't have all the answers yet, but one thing is already clear. The universe is far stranger, more resilient, and more surprising than we ever imagined. What was once believed to be the end of a star's story may actually be the beginning of an entirely new chapter. And somewhere in the darkness, circling the glowing ember of a dead sun, a silent planet continues its endless orbit, reminding us that in space, the impossible has a remarkable way of becoming reality.